Now, to determine whether this function is linear or exponential, you want to look at what's going on in the y's. Now, you also want to check what's going on in the x's, because if it weren't increasing by just 1, then you'd have to look at the combination of the x's and the y's. But because they're just increasing by 1, we can look exclusively at the y coordinates, which they're using function notation and saying f of n. So when you look at the y coordinates, notice how it doesn't look like a gradual change or a consistent change. Notice how quickly the numerator and denominator are changing. If you're good at recognizing patterns, you might notice, well, it looks like in the numerator, it's times 3, times 3, times 3. And then in the denominator, it's times 2, times 2, times 2. So times 3 in the top, times 2 in the bottom. Well, that is an exponential relationship where it's multiplicative instead of additive. So instead of adding or subtracting the same thing, which would be a linear relationship, linear being like y equals mx plus b, instead we see a multiplicative relationship. So we could eliminate these linear options. And in case you ever forget what the exponential form looks like, you can go to our program. And remember, there's certain programs that are simply informational. We're gonna go to alpha cosine to get right to the f's. And we're going to go into function. And this one is one of those programs that have multiple options. We're going to go to number 3 to see all things exponential. So in exponential form, it's y equals a times b to the x, where b is the common ratio and a is the y-intercept. So we just discovered what the common ratio was. Another way we could find that ratio is you can always take any of the y's and divide it by the one immediately to the left. And the reason we do that is because we're essentially trying to figure out how do you get from left to right by multiplication. And so to go the other way, we do division. So let's say if I go alpha y equals to get my fraction feature, and let's say I do 81 over 32, and then I'm going to divide by, and let's go ahead and do alpha y equals, so 27 over 16, and I get my 3 halves. And notice I could have done the exact same thing with any other fraction. So I could have done instead, let's say 9/8 divided by, and I'll go to my fraction here, 3/4. So we get our common ratio as 3 halves. And since the form was a times b to the x, the 3 halves is what should be raised to the x, or to the n in this case, making a the correct answer. In case you're curious why the 1/2 is there, because the y-intercept occurs when x or n is 0, and that's why you get 1/2 for the y-intercept. But because the ratio was 3 halves, the answer is A.